Okay, so now we will talk about chemical formula. As I have already talked about previously, often we write water as H2O. Now this is the chemical formula for water molecule. So H2O represents basically one water molecule, right? So what is the meaning of say 21 H2O? 21 H2O means 21 molecules of water, right? So basically 20, this means 21 into 1 H2O. Since one water molecule is 1 H2O, this is just one water molecule. Also 21 H2O, how many atoms does it have? It has 21 into 2, which is equal to 42 hydrogen atoms, right? And 21 into 1. You see oxygen has no number, but here oxygen is present, so 1 is there. So 21 into 1 is 1. So overall 21 oxygen atoms. You understand this thing? Very basic stuff. Okay, so this means that, as I was saying, each molecule of water has 2 hydrogen atoms combined with 1 oxygen atom. Now, you see, a chemical formula is a symbolic representation of one molecule of an element or a compound. So, important students, this is a definition. Now, what does chemical formula do? It basically provides information about the elements present in the molecule and the number of atoms of each element. So as I was just telling you, see, so 1 H2O is one water molecule, basically 2 hydrogen atoms and along with 1 oxygen atom, right? Just a second. Yes, 1 oxygen atom. Okay, now, so that's the story, how it goes. So as I was saying, as there is no number, you see, as there is no number besides, so it means that there is only one atom of that element present in the molecule. See, H2O. So 1 oxygen atom. Good. So what about cooking salt, students? See, there are some more examples of chemical formula. We have already talked about water molecule H2O. Now here we have got sodium chloride, NaCl. Here this is sodium, this is chloride. So NaCl basically represents one sodium atom and one chlorine atom. See over here, one sodium atom and one chlorine atom. What about ammonia, NH3? So ammonia is NH3. There is nothing written over here, so this means just one nitrogen atom. And how many hydrogen atoms are there? 3. So this means 3 hydrogen atoms. Okay. What about glucose? So as the number itself you can see over here. So overall 6 carbon atoms, 12 hydrogen atoms, and how many oxygen atoms? 6 oxygen atoms. So you see, a chemical formula tells us the types of atoms and the number of each type of atom in one molecule of a substance. Okay, students. Now let us again look at some common compounds and their chemical formula. So water, it's just H2O. Next glucose, it is C6H12O6. Next salt, sodium chloride, NaCl. Next ethanol, C2H5OH. Ammonia, NH3. Sulfuric acid, H2SO4. Let me zoom it a bit. Okay, I think now it's better for you students. Right. See. Next methane, which is CH4, and then we have sucrose, C12H22O11. Okay, so you have to remember this Thanks, students. Okay, let me ask you a very interesting question. Suppose there are, let me ask you, here you see there are three substances. Okay, now the smallest unit of this substance is A2B3, the smallest unit. So basically the molecule of this substance is A2B3, whereas the molecule of this substance is A3B2. Okay, and the molecule of this substance is just AB. Now tell me, what are these? First of all, you see each of them don't have either A or B. They don't have, because if we have just A or B, then these two will be two elements, right? So what we have here are three compounds. Okay, now interestingly, each of the molecule, look, this has 2 A atoms plus 3 B atoms, whereas this one has 3 A atoms plus 2 B atoms. It's different. This one is different. Again, this one has just 1 A atom plus 1 B atom. So in a way, all these three compounds are different. So here we have three different compounds. So interesting point to note, students. So you might be previously wondering whether they are mixtures or not. No, they are not mixture, because I have already told you that the smallest unit of each of them are these molecules. Now look at the structure of these molecules. These two molecules are different. Again, these two are different. So this means that we have got three compounds which are very different from each other. Although all these three compounds are made using these two elements only. See the fun? So here we have three different compounds made from just two elements, right? And why? What is the fun in this? The fun here is basically the difference is caused by this fact that here if A has some number, say n, and B has some number, say k, then this means that the molecule here has n number of A atoms plus k number of B atoms, and there is chemical bonding between them, right? And this is what is related to atomicity, the next concept we are going to learn. Now in chemistry, atomicity implies, this is important, students, again definition, note, atomicity implies the total number of atoms present in one molecule of an element, compound or a substance. Let us see how to calculate the atomicity. We have just done that actually. Now, for example, oxygen exists as a diatomic molecule. It means that a molecule of oxygen contains two atoms. See, two atoms. So what is the atomicity of oxygen molecule? Just 2. Similarly, a phosphorus molecule, which is P4, how many atoms? 4 atoms. And a sulfur molecule, S8, has how many atoms? 8 sulfur atoms. So their atomicity are respectively 4 and 8. Now for molecules containing more than one atoms, how do we calculate? Again, it's very simple. You just have to count the number of each atom, and that would be its atomicity. So let us take an example. So one molecule of sulfuric acid, H2SO4, what does it has? H2SO4. So 2 H atoms, next plus 1 sulfur atom, next it has got 4 oxygen atoms, right? So what is the atomicity? See the number 4 plus 1, 5, 6, 7. So its atomicity is just 7. That's it. Similarly, one molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. So atomicity of water is 3. Now, let us talk about atomicity of some elements. So hydrogen, remember hydrogen exists as hydrogen molecule H2, so its atomicity is 2. Helium, inert gas, so atomicity is just 1. Lithium, again 1. Beryllium, 1. Sodium, 2. Oxygen, remember it exists as O2, so just 2. Again, fluorine is 2. Neon, 1. Sodium, 1. Magnesium, 1. Phosphorus, 4. Sulfur is 8.